Hello, friends. Welcome to what I think is an exciting topic, proofs. Now, we already did in a previous lesson, lesson 24, algebraic proofs. And that was kind of like an introduction, a light introduction to proofs, the way that they work, and the way, and it was basically two column proofs there. But here we're introducing geometry. There we were doing algebra, what you've done before, and just showing that you have to justify each step. Here, we are doing geometry. And so this is the real introduction to geometric proofs. And we set it up in this two-column style. When mathematicians write papers, they're not doing things in the two-column proof style. But we do that this way so it's really clear. What exactly am I saying? What's the claim? And how do I know that that's true? That's the whole idea. Here are some kind of given premises, some starting points. Okay, well then what's the next thing I know? What's the next thing I know? In this clear deduction process from one step to the next, and then how we know it's true. So let's take a look at some examples. That's the best way. So for example, this is something I actually went through. I kind of went through the proof when I introduced this idea, but can we prove the idea that the sum of the interior angles of a triangle is 180 degrees? The answer is yes. Here's a given. So given that P is parallel to Q, okay, so let's just take a look here. So we've got this diagram. Here's line P, here's line Q. I labeled it that P is parallel to Q. And we got these angles in here. Okay, so we've got parallel lines, I've got transversals. Okay, and then, well, I know if I've got parallel lines, then I know some of these angles can be congruent or supplementary, something like that, right? And so I'm starting to put together my thoughts. Really closely inspect the diagram, look at the given information. Sometimes it's a few things that you're given, and make sense of it. Draw on the diagram if you need to. Proof, right? What is it that we're trying to prove? That the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. So I'm looking to see that these three angles add up to 180 degrees. Okay, well, my starting point would simply be that P is parallel to Q. How do I know that? Because that's given, right? So given can be used as a reason if it comes from the given information. So that's the given information. Now, what's my next step? Well, I know from parallel lines that I have some of these angles that are going to be congruent against supplementary. So how am I going to start going about this? Well, um, I know that 4 and 1 are going to be congruent, and I know 5 and 3 are going to be congruent. Those are alternate interior angles. Why am I thinking this way? Well, I'm looking at this, and I'm like, well, that adds up to 180 degrees, right? 4, 2, and 5. So that means if 4 and 1 are the same and 5 and 3 are the same, then 1, 2, and 3 have to add up to 180. So I mean, I just basically just went through the proof. Now I just have to lay out the steps. Okay, well, I know that 4 and 1 are the same and 5 and 3 are the same. So angle 4 is congruent to angle 1, angle 5 is congruent to angle 3. How do I know that? Because I know that when lines are parallel, alternate interior angles are congruent. That's how I know that. Okay. I am going to be putting things into an equation, adding things up. So then I'm also going to say the measure of angle 4 is equal to the measure of angle 1. The measure of angle 5 is equal to the measure of angle 3, right? I'm putting like two things, but it's the same reason, so I can kind of combine. I can do this sometimes. So how do I know this? Well, it seems really obvious. It's very simple, but it just comes from the definition of congruent angles. That if two angles have the same measure, then they are congruent, right? So that's the definition of congruent angles. That's how I know that. Okay, now I've got to put together this idea that 4, 2, and 5 add up to um, 180 degrees. So the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is 180 degrees. How do I know that? That's the angle addition postulate, right? And so now I just substitute. Look, instead of 4, I put 1. So 4, I substitute 1 in, and then I substitute for 5, I substitute 3, measure of angle 3. So now I have it. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. How do I know that? The substitution property of equality. I substituted 3 and 1 for 5 and 4. QED. I explained what that means, quod erat demonstrandum. So that's what was having to be proved. This is the thing that had to be proved. Notice, by the way, I don't put down here prove. I almost hesitate to say it because I don't want to put it in your head, but I do see students do this where they'll write prove. Right? That's not a reason. Prove is not how we know that this thing is true. Right? This has to come from the previous things that we had done. prove never goes in as a reason. So what's the general strategy here when you're dealing with proofs? First of all, read the given information. Read it again, right? Draw the diagram, draw on the diagram. If you're given a diagram in like a textbook or something, copy it onto your paper. So draw the diagram, draw on the diagram. Anything that's congruent, parallel, label it in the diagram and really familiarize yourself with what's going on there. Then read the proof. If you're paying attention and you're thinking about the diagram and the given as you're copying it, you may already have had kind of an idea of what you might have to prove. Okay. So then you look at it and you think to yourself, well, given all this information, really familiar with the diagram, the given information, how could I figure out that this thing is true? And that's going to be different. That's a little bit of an art for every proof. There's no like cut and dry formula, like you just apply this formula and it works every time. This is some serious deductive reasoning. And sometimes there are proofs that are quite long. Um, then you make two columns, start with the given information. It's always a good place to start. Start with the given information. And then also just to know that prove is not a reason. You never write prove in anywhere in the in the proof. Okay, so here's another example. Given. So here the given is just this diagram. Okay, and then prove that angle 1 is congruent to angle 3. Now let's assume for a minute that we don't have the vertical angle theorem. So what we're doing here is we're proving the vertical angle theorem. Right? We're proving that vertical angles are congruent. So we've got to back up a little bit because we already know that that's true. But again, we're going to justify it now, prove it step by step. Well, as I'm looking at this, I realize, well, you know what? Like this, 1 and 2, this is a linear pair. And also this, 2 and 3 are a linear pair. That's good information to have, right? Because if 1 and 2 add up to 180, 2 and 3 add up to 180. So 2 plus 1 is 180, 2 plus 3 is also 180. So that should seem pretty simple, right? So, and even as I'm talking this through, I'm coming up with like a different way than I had already done it. And that's okay. That's going to happen. But again, the steps should follow. So, all right. So what am I starting with? There's no given statement to start with, but I can start with what I have just from the diagram. Again, 1 and 2 are a linear pair. So 1 is supplementary to 2. So linear pairs are supplementary. That was something we already had. That was another theorem that we already had. So I can use that here. Angle 3 is supplementary to angle 2. Okay, that again, there's a linear pair. So linear pairs are supplementary. Okay, so then that means the measure of angle 1 plus the measure of angle 2 is 180. Measure of angle 3 plus the measure of angle 2 is 180. I'm going to be doing some algebra, so I need to have equations. So I get this into equation form. How do I know this? Because this is the definition of supplementary angles, that their measures add to 180. Okay, now the subtraction property. Well, see, what I could do is just set these both equal to 180, and then I'd subtract angle 2, and that would work. But here, what I do instead is I say I solve for a measure of angle 1, I solve for the measure of angle 3. How do I do that? So what did I do? The measure of angle 2 is on the other side, and I'm subtracting it. So I did subtraction. I subtracted the measure of angle 2 from both sides. So how do I get from here to here? The subtraction property of equality. Subtracting the measure of angle 2 from both sides. Now, look at this. Measure of angle 3 and measure of angle 1. They're both equal to this same thing, 180 minus the measure of angle 2. If they're equal to the same thing, that means they're equal to each other. So the measure of angle 1 equals the measure of angle 2. That's the transitive property of equality. Two things that are equal to the same thing must be equal to each other. So that's the measures are equal. Now, angle 1 is congruent to angle 3, right? Look carefully. I want to prove that they're congruent. If I just stop at the measure of the angles, I haven't really finished it yet. But it's one more simple step that angle 1 is congruent to angle 3, and that's the definition of congruent angles. Quod erat demonstrandum. We're done. Okay. Proofs are not easy. I think that's one reason why students really struggle with them and they don't like them very much. They're not easy. They require abstract deductive reasoning. You've got to think through a problem. You're coming up with your own solution. It's not a cut and dry, here's the problem, here's the formula, you just plug and chug and you're done. But this is part of where the beauty of physics, the beauty of Freudian slip. The beauty of geometry lies, right? They're both beautiful in different ways, of course. Geometry is just pure deductive reasoning based on space and quantity. Um, and you can see it. You can see it here. Everything fits, right? So if we're given these initial ideas, this last thing has to be true. It has to be true, and you can prove it. So beyond a shadow of a doubt, this thing has to be true if these initial things are true. And we build up this entire huge system of ideas that are perfectly logically related to one another. So thanks for watching. Don't forget to like and subscribe and share.